If you're watching this video, you probably want to see how to prove quadratic formula or how the quadratic formula is derived. So that's exactly what I'm gonna show you. So recall that the quadratic formula says that ax squared plus bx plus c, if the equation is in this form and a cannot be 0, the solution to this, which is x, is precisely negative b plus or minus square root of b square minus 4ac, and all of this over 2a. But how do you get this one? This is exactly what I'm gonna show you. So I'm gonna clear this one and start from the beginning. Let's write the standard form of the quadratic equation, which is gonna be ax squared plus bx plus c equal to 0, and a cannot be 0. So the first thing first I want to do here is I want to get rid of this coefficient, which is this a right here. So I'm gonna divide everything by a. So this one obviously gonna cancel each other, and you're gonna be left with x squared plus b over ax plus c over a, and 0 divided by a is just 0. That's good. Now the next step. Rewrite this one, x squared plus b over ax plus, I wanna add something. I don't know what I'm gonna add, but I wanna add something here, so I'm just gonna leave this one blank. That is gonna be equal to, I'm gonna add same thing over here and bring this one over here, which is gonna be negative c over a. Bring this one over here. So I haven't really changed anything here. If you cancel this dash and then bring this one over here, you're gonna get this one. And if you multiply this whole thing by a, you're gonna get the top one. So I haven't changed anything. To find out what you want to put here, you want to look at the coefficient of this x term. So the coefficient of x term right here is b over 2a. Just leave it like this, and the next step you want to do is take same thing over this one, b over 2a, and this time square this. So when you square this, you're gonna get b square minus 4a square. So actually what I'm trying to do here is I'm trying to make this left hand side a perfect square, so I can take the square root of left side. So that's all I'm trying to do here. And so if you do that, you're gonna get x squared plus b over ax plus, and add this one over here. That's gonna be b square over 4a square, and that's gonna be equal to b square minus 4a square minus c over a, and this whole thing. So I just made this one a perfect square, so you can rewrite this as x plus b over a square, and if you square this, you're gonna, oh sorry, 2a, x plus b over 2a square. Whatever you get here when you divide this term by 2 is exactly the same thing. It's gonna go over here. So this is same thing. These two guys, they both are same, and I wanna make the same denominator over here, so I'm gonna multiply by 4a. If we do that, it's gonna be b square minus 4a times c is 4ac over, and this is gonna be 4a square. Alright, so if you take the square root of this both sides, because you are taking square root, you have to put plus or minus. I'm gonna erase this and continue here. Oops. Okay, let me draw a line. Okay, so we got x plus b over 2a is exactly plus or minus. You can take the square root of top side. Oh, I mean, sorry, you cannot take the square root of b square minus 4ac, so it's gonna be like this. You can, however, take the square root of this bottom side. So if you take the square root of 4a square, what you gonna get? You're gonna, the square root of 4 is 2, square root of a square is just a, so you get 2a. That's gonna be 2a. So you're almost done. So just take this one over here. So we get x is equal to negative b over 2a plus or minus square root of v square minus 4ac over 2a. Because they have the same common denominator, which is 2a, we can rewrite this as x equals negative v plus or minus square root of v square minus 4ac over 2a. So this is basically the proof of the quadratic formula.